Hello everyone, welcome back to this video series on clinical SAS TFL programming. In this video, we will take a look at the lesson which is talking about overview of treatment emergent adverse events table with both subject count and event count being presented. So here we have the shell for the output which we are going to generate. So the title says overview of treatment emergent adverse events, which means that we need to consider only the events which are treatment emergent for this table. And this table is to be generated only for the subjects who are part of the safety analysis set. And then we have three treatment dose levels present, and then we have our number of subjects in each treatment being displayed in the header. And then we have this indicator of the statistics that are being presented, small n, percentage, and small m. The small n stands for the number of subjects experiencing a particular adverse event of that category which is displayed on a particular row. And the percentage is based on the number of subjects who experienced an event divided by the total number of subjects in that treatment. So small n divided by capital N multiplied by 100 gives the percentage. The m is the total number of events experienced by the subjects. So if a subject experiences one more than one times a particular event, we count the subject only once in the small n count, but we count all the instances in the m count. So that is the difference between the subject count and the event count. So we have some notes which says percentages are calculated based on number of subjects in treatment of the population specified. And then small n is the number of subjects with at least one adverse event. And E is the number of events. And then there are some table footnotes, so which talks about one events with relationship recorded on CRF as possible or probable are considered as drug related, and events with a seriousness recorded on CRF as yes are being considered as for serious adverse events. So these are some footnotes for the table, and there are some programming notes which says display all rows presented in the shell even when there are no events reported in that category, which means our output should exactly look like and should have the same number of rows as how we have it in shell. Even there can be some rows wherein no subject has experienced event in any of the treatments, but we still need to present a row for that. And then it says do not present percentages when the subject count is 0. So percentages and m counts need not be presented when the subject count is 0 in this table. So instead of going through the pre-written code, we will go and program this table in the live mode. So let us go to our SAS session. So here I have included the data file which has the data for this output. So similar to the previous videos, let us try to write a statement which creates our output window and also log window before each run of this entire program. And let's also write a statement or step to create or delete the work library datasets. So we also need to add one keyword called no one. So when we run this proc datasets to kill the all the datasets present in work library, and if when there exists no dataset in work library, when this code gets executed, we get a warning in the log saying that there are no datasets in the work library. So in order to avoid that warning, we can make use of this keyword called no one. And then so we have our %include statement which is calling a SAS program which contains the data for this lesson. So let us run till this point and then see how it goes. So if you see, it says no matching members in the directory. So we have included no one, still the warning is produced, but let's ignore for that time being. So we have ADSL dataset with 45 observations and ADAE dataset with 263 observations. So let us try to quickly examine the contents for ADSL dataset. For contents, data is equal to ADSL run. So we have four variables. The first one is safety flag, SAFFL, and the second one is TRT01AN, and the third variable is TRT01PN, and the fourth variable is usage ID. So as we need to generate the table based on safety flag, we need to consider the actual treatment the subject has used. So let us check the unique values in TRT01AN in ADSL dataset. So we can make use of our PROC freak. So ADSL unique values in TRT01AN can be checked using this piece of code. So we have three unique values 0, 54 and 81, and there are 15 rows with value of 0, 15 rows with value of 54 and 15 rows with value of 81. This means that there are 15 subjects in each of the treatment and there are total of 45 subjects. So now let us do the same thing for our ADAE. Let us examine the variables present in ADAE dataset. So we have around 10 variables. So how I am telling that there are 10 variables is this is the variable number. So in the order in which they appear in the dataset, the maximum number seen across all these rows is 10. So we have 10 variables in the dataset, out of which the first one is AEACN, action taken with study treatment because of an adverse event, and AED code, which is the dictionary derived term or the preferred term for the adverse event experienced by the subject. And then we have this AEREL variable, which is used to capture the causality of the study treatment for that adverse event. So whether the adverse event is because of the study treatment which the subject has taken will be captured in this variable called AEREL. And then we have this variable called AESDTH, which says results in death. So this flag will be populated as Y if an adverse event has resulted in the death of the subject. And then we have this variable called AESCR, which is used for flagging whether the adverse event is a serious adverse event or not. So it will have a value of Y if a adverse event is serious. And then we have ASTDT, which is used to capture the analysis start date or the adverse event start date. And then we have safety analysis flag, and then TRTAN, which is a record level treatment variable, and then we have TRTEMFL, which is the treatment emergent adverse event flag, and then we have a subject identifier. So we have now seen the variables present in this. So let us quickly examine the unique values present in all the variables of ADAE. So if we run our proc freak without any table statement, it will give a summary of all variables present in the input dataset. So let's run that and see. So here if we see, so let us clear the log first. So I have just used, I am there on the log window, and then sorry, I cleared output window. I am there on the output window and then pressed Ctrl E on my keyboard. So that clears the content in the output window. So let us go back to the code, run this piece of code again by using F3. And then we have, these are the unique values present in usage ID variable. So if you see, there are 3 rows with subject 1001 and 4 rows with 1002. This indicates the total number of rows in ADAE for each subject. So and then we have unique values of 0, 54 and 81 in our TRTAN variable, and SAFFL has a unique value of Y, and then we have different start dates. And then we have the unique values in AED code variable, and then next is AESCR. Out of all the records present in our dataset, all the records have a value of n. And then for AESDTH, so there is one record with a value of Y, and other records have a value of n. And the unique values present in AEREL variable are none, possible, probable, and remote. And then AEACN, all the values are missing on all the records. And then TRTEMFL has two sets of values, one is n and the second one is y. So we have examined the unique values present in some of the variable that we will be using to program this output. So let us come back and try to write our code. So the first step that we do is read and process the input data set. So let us do that. So the first one is, well, let's process ADSL and let's create a dataset called ADSL01 by using the input dataset ADSL. As we are trying to generate this output only for safety subjects, let's apply a filter for safety flag, and then as our regular practice, so in order to create the total column, let's use the values from TRT01AN and then output it, and then assign a value of 4 to this one. So in order to make our code reusable, so let us try to convert these values if of 0, 54 and 81 to 1, 2 and 3. If TRT01AN is equal to 1, then treatment is equal to 1. Sorry, this is 0. The unique values were 0, 54 and 81. So else if TRT01AN is equal to 54, let's make it as 2, and then let's make 81 as 3. So I don't need this. So we have now created rows to account the subject under total column. So let's try to run this code and see if there is any issue in the log. So this seems to be working fine. So there are 45 subjects with safety flag is equal to Y. So as we are outputting each record for the second time for total column, the number of records should be doubled. So 45 multiplied by 2 is 90. So this code is working as expected. So if we want to quickly check if everything is working fine or not, we can write a proc freak on ADSL01 and then write a simple proc freak on the treatment variable to see if the values are assigned correctly or not. So we are expecting values of 1, 2, 3 and 4. So we can further go ahead and then make it as TRT01 as a cross tabulation of this. So to see, like 1, 0 should become 1, 54 should become 2, 81 should become 3. So that is happening, and as each treatment, so all the values of 0 we have made as 4, 54 as 4, and then 81 as 4 to account the subjects under total column. So this is working as expected. So we don't need this code anymore, so we can just remove it. So let us do the same processing for ADAE. So let us copy this piece of code and then just reuse it here, but just change the input data set. So what here upfront we were asked to use only the events which are from treatment emergent adverse event. So I am applying the filter for it. The treatment variable in ADAE is a record level treatment variable which was TRTAN. So let us try to change that in these three instances. Now we have processed our input dataset ADAE. So there were 238 records with safety flag is equal to Y and TRT EMFL is equal to Y. So 238 multiplied by 2, 230 is 460 plus 8 plus 8 is 16, which is 476. So we have this code working as expected. Now the next thing that we do is to get the denominators or treatment totals and then create macro variables. Get treatment totals and create macro variables. So let us do that. So we have been using this step. We first create a dummy dataset which with all the possible treatment totals, dummy TRT totals. So we can make use of our do loop. Do treatment is equal to 1, 2, 3, 4, and then write an output statement within the loop and then end. So then we can make use of our proc freak to fetch the counts or number of subjects present in each treatment using ADSL01 as input. As we are not interested in seeing the output in output window, we can make use of proc no print option on the proc freak. So here let's call this dataset as TRT totals 01 and then let us rename the count variable as TRT total, and then as we are not interested in the percent variable, let us drop it using drop is equal to option. So now we have our dummy dataset and the dataset which has our actual totals. So what we need to do now is merge these two datasets, and then if a treatment is available only in dummy but not in the actual, we can set it to 0. For that we can make use of our merge step. So let us call this dataset as TRT totals, and let's use this dataset dummy TRT totals as the first dataset and TRT totals as the second dataset on the merge statement. And then we need to merge these two datasets based on treatment, and then we have to set the TRT total to 0 if a record is present only in dummy treatment totals but not in TRT totals. So then we need to write this if statement: if A and not B, then TRT total is equal to 0. So we have our denominators available now. So we need to create our macro variables. So how do we do it? We can make use of our calls input x to create this. For this we need a data step, so we do not need any output data set to be created for creating the macro variables. So we are using TRT totals as input, and then on this we are making use of calls input x. So there are two arguments are needed for calls input x. The first argument is for providing the names of the macro variables, and the second argument is for the variable which contains the values to be stored in the macro variable names. So for the macro variable names, we want to create the macro variable names which has TRT as prefix with the value present in the treatment variable. So we'll have the treatment variables created. So let's try to run the entire piece of code till this section by pressing F3 on the keyboard. So I have run this entire piece of code. Let's quickly examine the treatment totals dataset in work library and see if it was working fine. So we had 15 subjects in each treatment, and so we should have 45 on the total row. This is working as expected. So now the next thing that we need to do is to fetch the actual counts for the table body. So here again we'll try to make use of PROC SQL to get the counts. So here I am making use of PROC SQL. So we need to get the counts at treatment level. So I am making use of or selecting the treatment variable, and here what we need as per the layout is both the subject count and event count. So if a subject exists more than once, for small n we need to count the subject only once, and for m so we need to count all the instances. So for that what we can make use of in PROC SQL is similar like how we have seen in other AE tables. We can make use of the distinct keyword on use sub jd variable, so that this will give us the subject counts. So if we do not use distinct keyword, it would count all the rows irrespective of the number of occurrences. All the occurrences would be counted. The simpler case is if a subject has only uh, if a subject has two adverse events, so a subject would be counted once under that treatment because we have used distinct keyword. And here when we do not use the distinct keyword, the count would give a value of 2. So in this, the second thing that without distinct is nothing but our event count. The input data set for our counts is ADAE 01. So but here what we are trying to do here is to fetch the counts for each row. So here we need to process things separately for each row and then append them together. So here we are trying to fetch the counts for this first row. So let us try to identify that first row with a value of 1. So I'll create a variable called order, and I am assigning a value of 1 to it. So here for the adverse events row. So what we need to do is we can just filter for TRT EMFL is equal to Y. So let us try to run this piece of code and then see. So we have our, so I missed adding this group by because we need to group the counts at each treatment. I need to add group by. So I have added it and then let's open count 0, 1. So for the row 1, for under treatment 1, there were 11 subjects experiencing one event, at least one adverse event. And then there were 38 events experienced in total, which means out of the 15 subjects who were present in treatment 1, 11 subjects had at least one event, and then these 11 subjects have experienced a total of 38 events. So this is how the numbers will be interpreted. Similarly, for the second treatment for row number 1 in the table, so there were out of the 13 subjects, out of the 15 subjects who were present in the treatment 2, 13 subjects experienced at least one event, and these 13 subjects have experienced a total of 84 events. So this is how we interpret the numbers for this table. So now let us come back to the program and then try to create the entries for other rows as well. Now if we come back to row 2, so here it is drug related adverse events. So one approach is to create a separate data set for each of these rows and then append them. So but here we will make use of our union all core. So we don't need this semicolon, so which is nothing but we are trying to append things from a second query or second select statement query to the previous one. So what we are trying to do here is select 2 as order, and then I'm repeating the process, but the filter condition for row 2 was drug related event. So for drug related events, so we were asked to use the variable called AEREL and check for the values of possible or probable in AEREL variable. So if there is a value of possible or probable, we are considering that adverse event as drug related adverse event. So let us now come back and then change the filter conditions. So as we are making a comparison here, so it's best practice to convert the case so that even if the values have different case, the query works fine. So here what we have done is, so creating one more set of rows for second treatment, and but here the counts are being obtained for the second row with the filter condition of where upcase of ARL in possible or probable. So let's add a semicolon here at the end and then try to execute this code now. So for we have identified the drug related events with a value of 2 in the order variable. So let us open count 0, 1 again and see if we see. So there are the rows which are coming for row 2 now. So under treatment 1, there are 5 subjects who experienced at least one drug related event. And these 5 subjects have experienced a total of 10 adverse events which are related to the treatment. So let's continue. So instead of creating, what we have done here is instead of creating separate datasets, we have made use of union all core to append the rows from a next query. So what we can do now here is for the third query, let us do that. So let us change the value to 3 as order. Let us go back and check what was there in the third row. It is related to deaths. So for the third row, so we are supposed to use for deaths. We have seen that there was a variable called AES DTH. So this variable will have a value of Y if the subject has died because of if the event caused death of the subject. So we'll add the filter for it and let's continue adding for other rows as well. So for row 4, so let us now go back and see what was being presented in row 4. It is serious adverse event. So as per the CDS case DTM standard, we will have a value of y in AESCR variable if the adverse event is serious. So let us now replicate this and then try to add it for fifth row. So for fifth row, let us go and check what was the condition. So it is drug related serious adverse event, which is a combination of filter for serious adverse event and drug related. So we have already written filter for serious adverse event here. So for this we need to just add. So this is drug related and then serious. So drug related serious adverse events would be obtained. So we need to change the order to 5 here because this is for drug related in the fifth row. So and now for sixth row, let us go and check what is being presented. So for sixth row, it is adverse events leading to permanent discontinuation of study drug. So let us now come back and then so here we have a variable called AEACN, so which is talking about what is the action taken or the study treatment. So let us now come back to the code and then add that condition. If the drug is withdrawn, so we'll have a value of drug withdrawn for the in the variable AEACN. So let us now go back and see what was the row. Adverse events leading to permanent discontinuation of study drug. If the study drug is discontinued, we will have a value of drug withdrawn in AEACN variable. So we have added that. Now the last row is drug related and adverse event leading to permanent discontinuation. So which is a combination of this row and the second row which is drug related. So we can just replicate this row and then add an additional filter for drug related which was uppercase of AEREL in this one. So let us run this entire piece of code. Before that, let's change this order variable and make it as for row 7. So we have run this piece of code. So let's open count 0, 1 and see. If you see, there are only rows for row 1, 2 and 3. When we does this like PROC processing, we will get only a row if there exists at least one row meeting that particular filter condition. So here we didn't have any rows which was having AESCR is equal to Y or any conditions which were meeting from row 4. We didn't have any rows which were meeting the conditions for these 4 or 5 rows. So for all these rows, there will be no row in the output dataset that we were creating. So but as per the requirement, we need to present the entire set of rows in the output. So let us create a dummy dataset for create dummy dataset and merge with actual counts. So for this purpose, what we will do is make use of Excel to generate the required lines of code. So here I was doing some practice. So here what was happening is so row 6 and row 7. I just copied the content from the shell and I'm just restructuring that here. So we don't need this row 7. Row 5. So this was the same label for this row 7. So I have restructured. What I have done is added numbers to this. So I'll make use of Excel functions to create some lines of code here. So what I wanted to do here is, let's try to create one row in the SAS code. So let's create a label column and assign the value of 200 to it. And in the dummy dataset, I want to create this order is equal to 1, and I want to assign the value of label which was coming for row 1. So for row 1, the label was adverse event. So I want to create lines of code which has labels for all the rows which are present in this way. So for this purpose, I'll make use of Excel and Excel functions to create all the required lines of code. So I'll make use of the concatenate function. So if you see, so the first thing is that I need the text order is equal to, so I'm closing the I have put the text in the quotes, and then after that I want to put the value which is present in this cell. So I have selected that cell and then I'm using a comma, and then after this we need a semicolon after the assignment of order value. So I am putting that within the quotes, and then we also need the text of label is equal to, as label is a character variable, so I'm putting a single quote there and then closing this double quote for the text, and then we need the value from cell B1 to be displayed there, and then what we need is we need a closing single quote for the actual text which has to be displayed as label, followed by a semicolon, and then we need an output statement with the semicolon. So I have added that within the quotes. Now I have got that structure. I am just dragging it down till the last row. Now I have that complete piece of code available. So I'll just go back to my SAS session and then just paste it here. So all I have is, like, I have made use of Excel concatenate function to create the SAS code which is needed. So I am creating 7 rows here with all the labels that have to be displayed. So let us try to run this code and see if it is working fine. So let us open dummy01 dataset and then see. Yeah, it is working as expected. So now let us create a row for each treatment for these 7 rows. So dummy 01 is our input data set. Let's create dummy 02. So we need to replicate each of these 7 rows for all 4 treatments, 1, 2, 3 and 4. So and then we need to use an output statement within the loop to replicate each row for all 4 treatments. Let us run this and then see. So our expectation is that there are 7 rows in the input data set. If it is getting replicated for each treatment, 7 multiplied by 4 is 28. So we are looking for 28 rows in dummy02. Yes, that's what we have. And then let's open dummy dataset and then see. Now what we need to do is, like, merge our dummy dataset with actual dataset based on order and treatment, so that we can populate 0 counts wherever required. So let us merge our dummy and actual counts. So for that, let us sort the records and then merge. So for sorting, what was the data set that we had? We had count 0, 1, and we need to sort it based on order and treatment. So let us replicate this proc sort step for our dummies 0, 2 as well. And then let us use dummy 0, 2 dataset as the first dataset in the merge statement, and then count 0, 1 as the second dataset. And then let us merge these two datasets based on order and treatment. So let us call this output dataset as counts 0, 2. And then if a record is present only in dummy but not in actual counts, so for that particular order and treatment, if A and not B, so then we need to set here two variables to 0. Here we have subjects is equal to 0 and then events is equal to 0. So here we have created variables called subjects and events to to contain the number of subjects and number of events experienced. So we have to set those two variables to 0 in this step. And the next step is to, so otherwise let's try to run this code till this point in time and then see what is happening. So there were 28 rows in dummy and there were only 10 possible combinations in actual data. So we are setting the other row counts. Say for example, we didn't have any subjects who are meeting the filter conditions from row 4. So row 4, 5, 6, 7, everything is created but with 0 counts here. So now let us try to calculate the percentage. So for that we need to get our treatment total into our counts dataset. So for that we need a sort and then we need a merge. So for sorting TRT totals, we need to use sorted by treatment. Let us replicate this proc sort and then so this dataset called count02 also needs to be sorted based on treatment, and then let us use count02 as the first dataset and then treatment totals as the second dataset. We need to merge based on treatment alone. So here in this case we need to keep only the records which are coming in from count02 only. And then let us name the output dataset as counts03. So let us try to run the code till this point and then see if we have treatment total variable available in count03. So we have our treatment total available now in count03. Now we can make use of this one to calculate our percentage. So let us create a new dataset called counts04 using counts03. So here in this, so let us create a variable called CP again, and let's assign a value of length 30 to it. So here we were asked to not present percentages or m count when subject count is 0. So we have to check if subjects not is equal to 0, then here we get CP is equal to put of, so subjects 3 dot, and then we need to put parenthesis percentage in the parenthesis. So let's do that. So next thing that we are doing here is count the, if we here we need to divide subjects by TRT total so that we will get the percentage. So divided by treatment total multiplied by 100, and then let's present the percentage in the format of 5.1. So here, and then we need to close this. After this, here we need to present event counts as well. So let us concatenate our event counts as well. So using put function again with 3 dot as a format. So otherwise, so what we need to do is if subject count is equal to 0, we can just create CP as just present the 0 present in the subject count. So here this is subjects, here also this is subject. So let us try to run this piece of code. Let us name the output dataset as count04 and then run this piece of code. So there is some issue. It says numeric values have been converted to character values at places given by 2388. So there is this double CP is equal to, so let us try to remove that and then run it once again. So everything ran fine. Let us open count04 and see how our CP is organized. So 11, which is subject count, 73.3 is the percentage, and then CP, and then CP variable, the last component has the event count. So 5 subjects, 33.3% of subjects experienced at least one event, and those 5 subjects experienced a total number of 10 events. So now let us try to add a space here after the closing parenthesis but before the event count. And then till this point what we have is the treatments as rows, but we need to restructure this to columns. So restructure the data such that treatments are present as columns. So how can we do that? We can make use of our proc sort followed by a proc transpose. So count 04 needs to be sorted based on, so what are the variables which we need to have as rows. So order, label needs to be present as rows. So let us keep those in the by statement for transpose as well. Let us use count 04 on the data is equal to option, and let us create count 05 out of this, and let us make use of prefix is equal to option on the proc transpose statement. So to add a prefix of trt to the newly created variable names. So the variable that needs to be transposed is cp, and we want our treatment value names to become the names of the newly created columns. So we can try to execute this piece of code and then see. So we have this code run fine and without any log issues. Let's open count 05 and then see how it is. So we have the final data set which looks exactly like how it has to be presented in the report. Now let us try to generate the report portion for this. So here let us write the proc report code. Proc report input data is our counts 05. So let us make use of no windows option and headline option, head skip option, and then let us give a line size of 150, and then let us use the column statement to list the variables that are to be presented. So we need order column so that the rows are ordered in the way uh, they have to be presented in the report. So then we need to present TRT1, TRT2, TRT3, TRT4. So let us now write define statement for order. So we only need this for ordering the rows but not print it. So we'll make use of no print option. And then for define label, so here we, as per the shell, we did not want to display any header for that column, so I have given a null header. If I don't give this, the name of the variable would be printed. So let us use a width of, let's say 50, and then use the flow option. So if the text is length is more than 50 characters, if we do not use flow, the text would be truncated. For that to be avoided, so we have to add flow option. And then so we can write our define statements for our individual treatments. So for dose level, so we let's call this as dose level 1, and then we have to present our n is equal to on the second row, and on the third row we wanted to present this statistic in marker, so n percentage and m on the third row. So for each set of the double quotation or single quotation we add, so everything gets displayed on the subsequent row. So this entire first set of parenthesis text gets displayed on row 1. So we have used a second set of parentheses. This gets displayed on second row, and then this gets displayed on third row. This is an alternate way of uh, uh, fetching labels onto new rows instead of using a split character. So then let us use a width of 20 for this row, and let's also add a flow for this, and then let's try to the name of the macro variable which will have the treatment total for first treatment will be TRT1, and then let us try to replicate the rows for other treatments. So 2, 3, 4, 2, 3, For fourth law, it is total. So let us put that way. So the name of this macro variable also changes. So it is 4. So we don't need a break or skip anywhere in between. So we don't need to add anything in the compute block. So let us try to execute this entire piece of code and see if it works fine or not. Yeah, this ran fine. So if you see, so we have all the rows displayed as in the shell, and then we have our capital N value displayed in the header, and then the statistic followed by the N percentage and event count. So this is how we can program a overview of adverse events table from scratch in less than 45 to 50 minutes. Thank you for watching. Keep learning.